All right, I'm going to do this a little bit off. I'm going to skip chapter 7 for today, and we're going to come back to that tomorrow. Remember, I have to leave today right after 10 o'clock because I'm going out to O'Fallon, to Hope High School. So I'm going to jump into chapter 8, and if there's time, even chapter 9. In an ideal world, we'll get done with that by around 9 o'clock. And you'll take a break, and then we'll come back and we'll do 4 more of the problems that you were assigned, if we've got time to. Otherwise, we'll just do a couple of them. But those are the last ones that I'm going to do then, and the rest will be up to you. So we're on about page 215 of the PDF. It's how to work with data types. The good news is the majority of the data types in here, you already know what they are. You know what an integer is, you know what a float or a double is, etc. Some of these variables go by different names in here. All right, so sometimes as a programmer, and you're going to see this when we go back and forth between C# and SQL Server, that it might be called a char or a varchar in SQL Server, but it'll be called a string in C#. Does that make sense? All right, it's just, two names for the same thing. So we'll talk about the different data types and then how to convert data back and forth. Now, hopefully you remember this. We talked about it before, and that is this versus this. And I told you before, if it's implicit, the software does it. Well, that's what they'll talk about in here. When it's explicit, you do it, and that's what they'll talk about in here. So that's what the chapter will end on. Just remember, explicit, you do it. Implicit, the system does it for you. All right? So, as it says here, a column's data type specifies the kind of information the column is intended to store. That should make sense. All right? Most of the major data types are shown right here. Remember, for characters, there's actually 3 types that we can use. We can use char, which is fixed length. We can use varchar, which is variable length, and we can use nvarchar, which means variable length, but also provide for the Unicode character set. Numeric, there's a lot of them. You're going to see them in here in just a minute, okay? Date and time, one of the things you're going to be required to do on your next assignment, all right, the one that you'll be working on next week, on that assignment, all right, is to work with dates. So we'll put something in for a customer, like, or an employee, we might put in a hire date, that kind of thing, all right? So we'll talk about dates and times, and then you've got what are called lobs. And if you look on the screen here, it says large strings of characters or binary data. Let's suppose that I had a database that I had for, authors of a book or different books. It was a publishing company. If I want, it wouldn't really make a hell of a lot of sense for me to store an entire book in a database. But maybe I do want to store it someplace. And I can store that in one of these large objects. Plus, when you've got things like, binary files, etc., and we'll get into a little bit of that stuff, you store those in lobs. There's different kinds of lobs, so you'll see those. I'm not even going to touch on the spatial stuff. As it says, it's geographical values. So if we were doing something in here where you were working with GPS or some kind of coordinate system, you could use that. All right. So first they talk about the character types. And again, you can see these right here. Char, as we mentioned, is fixed length. Notice that the biggest size you can make a char, the biggest size, that is 255. Now that's pretty big, and that probably would hold most things that you wanted to hold, but not necessarily everything. All right? A varchar is variable length. So look, if you would please, the good thing about a char right here is it uses exactly what you tell it to use. So if you say char 2 and you put in this, it takes up 2 characters. If you say char 10 but you only put in 2 characters, it fills up the first 2 and the other 8 are blank. Notice the difference with a varchar 10. It only takes what it needs. So with a char, it takes everything that you've specified. With a varchar, it only takes what it needs. Now, hopefully that makes sense. All right? So again, char, fixed length, varchar, variable length, fine. It says, by default, MySQL 6 and later use the UTF character set for char and varchar types. All right. So sometimes you will see in here char, sometimes you'll see nvarchar, and they do mention it in here. It's not really that big a thing, one way or the other, because of what we're doing. All right. So next, jumping up to page 220, you see integer. And again, is that a surprise to you? You know that an integer is a whole number. But notice the different kinds of integers you can use. I'm not going to read any of these to you. All right? That big int is like using, in some programming languages, that's called a long. I couldn't read that number to you because I don't know what it is. But it's a big honking number. All right? The next one for a regular int, okay, that typically is the size of an integer. Negative 2 billion plus to positive 2 billion plus. All right? Then we have a medium int, and that's pretty specific to a database. Are you going to use that? It just depends. A small int and a tiny int. This is like, for lack of better words, this is like what's called a byte field. All right? You'll notice that with each one of these, they can be signed, meaning they can be negative to positive, or they can be unsigned, which means they're all positive. And if you look right here, this is the easiest one probably to tell the difference. All right, what? There's 256 possibilities, right? Negative 128 to negative 1 and 0 to 127. That's if you do it signed. If you do it unsigned, there's still 256 possibilities, but they go like that. All right? Sometimes it makes sense if you are working with numbers for a company or whatever, it may very well make sense to have a signed field. If sometimes it makes absolutely no sense to have it be a signed field. And again, I said this to you in an earlier lecture. I'm saying it again. All right? And that is technically only fields that could potentially be used in calculations should be signed. If you remember yesterday, the author took the area code and made that an int. I don't know why they did that. I think that was a foolish thing to do. Maybe they just did it for a factor to show it to you. I don't know. Notice some other stuff you can do in here. You can do what's called zero fill. So if I've got a thing of size 4 and I say zero fill, then it becomes 0099. Typically, the reason that you do that is to make sure everything lines up. And you want to specify to somebody, hey, that is 99. All right? If you notice on the bottom of the screen, this tiny int of size 1, that's a Boolean. Where, again, typically 1 is true and 0 is false. Okay? Fixed point and floating point, we've talked about these before, and I want to say this one more time. For instance, right here, if you look at the example, if I say here decimal 92, that means there's 9 digits. So the biggest number you can get has 9 digits. The 2 means there are 2 digits after the decimal place. That means that's the biggest number you can put in there. Does that make sense? Because there really is nothing else to say about it other than that. All right? You can use type double. You can use type float. I will tell you that virtually everything that you see in a database is type decimal. Whether it's numbers, whether it's dollars and cents or not. It's going to be very rare in most business applications that you won't use decimal. If you work for NASA, for example, you might use double and float. But for virtually any kind of company, all right, you're just going to use decimal, almost always. date and time I mentioned to you before, but I do want to say it again. And I said this to you yesterday. I'm saying it again right now. And that is, for instance, today is the 27th. That should be shown in the system as either 2018-03-27 or 2018-3-27. So you should say year, dash, typically month, dash, day. And it's recommended that you use the 0 there. That just takes away any doubt for what you mean. But both of those should work to specify today's date. Now, I'm not going to read this to you, but if you look here under the years, all right, they talk about, in here, they talk about, it says, notice that you can use different things in here. You look at this and you go, okay, timestamp. Combination of date and time from midnight, January 1st, 1970 to the year 2030. What the hell is that? First of all, January 1st, 1970 was a big day for the Unix operating system. That was the beginning of what was typically referred to as Unix epoch, EPOCH time. That's what that is. All right? And literally, it says combination of the date and time. It's going to store something for you like this. Year, month, day, the hour, the minute, and the second. If you don't specify these, they automatically default to 00:00:00. What you find is many companies don't use date time fields because the time, the time is irrelevant. And if they use date time fields, they've got all these 00:00:00 in their system that they don't ever use. So what you find is more often than not, they'll use a date as opposed to a time. Now, is that always the case? Of course not. All right. If you worked at a hospital, maybe that you were having a database where you were putting in birth times, and you'd want to put in hour, minute, second. So maybe there's a reason for doing that. Again, it's all relative. It depends on what it is you're working with. So they show you here on page 227 how MySQL interprets different things. Now notice it says 14-8-15. It says that'll be right. You're not guaranteed that'll be right. All right, I've seen instances where you put the 14 in there and it thinks it's 1914. That's why the recommendation is that you always put in 4 digits for the date. And I didn't mention this before, but if everybody would just for a second please look up on the screen here. I'm going to go to dev.mysql.com. And I don't want downloads, but I'll just change that. Yeah. Where? All right. So notice if I come out to here, right there, all right, I can go one further if I want to, but I go right here and go to reference manual. Click on that, and that brings you up the latest and greatest reference manual. The reason that I am telling you that, again, well, do we need to know this? Well, the reason that I'm telling it to you is anytime you're confused or you forget how something works, that's where to go. Everything that's in this chapter, plus one hell of a lot more, is in the reference manual. All right? And they give all sorts of, well, that works all the time except for this. Or they give you examples or whatever. All right? There, if you look, it says, by default, MySQL interprets 2-digit years from 00 to 69 as 2000 to 2069, and the years from 70 to 99 as 1970 to 1999. All right. And my guess is the reason for that, when you think about it, that's 52 years from now. All right. And the majority of people who are here right now, or I shouldn't say the majority, many people, I don't mean you guys, but many people who are here right now won't be here in 52 years. All right. All right. Then finally, they talk about a couple special types. They talk about the enum type in here, the enum, and after the enum, they talk about the set. Enum is short for enumeration. It's a user-defined type. And enumeration type is one that you set. That's the good news. The bad news is their examples in here just suck. I don't know why they wrote them like this, but they did. All right? This first one isn't bad. This one I just found really confusing. So notice, if we set up an enum, if we say enum and then yes, no, maybe, those are the three possible values. So if I set up a column that says, let's say we call that choice, and we made that an enum, yes, no, maybe. Those are the only three things that you can possibly put in there. Does that make sense? That's an enumeration. It's a user-defined data type. You'd say, well, why didn't you just make it yes, no? Well, if you made it yes, no, you wouldn't use an enum. You'd use a tiny int where 1 would be yes and 0 would be no. All right? So that's an example. The other one I thought was kind of a poor example. They said, well, we can also make a set. The idea with an enum is it can only hold one of those values at a time. With a set, it can hold one or more values at a time. So if our set was pepperoni, mushrooms, and olives, and we had just pepperoni, that works. If we have just mushrooms, that works. But notice if we have pepperoni and bacon, bacon's not part of the set, so it's not included. And if we've got olives and pepperoni, it puts them in the order they were in the set. So it would be pepperoni and olives. Like I said, kind of a dumb example. But they do mention here, if you want more than I just gave you, that's how you set up an enum. I'm probably not going to do anything with enums on your assignment. I'm more concerned that you have a fairly straightforward understanding of how this stuff works. What a database is, how you create a database, how you insert records, how you update records, how you delete records, how you search for records, etc. All right? The large object types I mentioned to you before, and you'll notice I'm not going to read these, but there's many of them. Look at the size, up to 4 gig. All right? So for instance, I could put maybe a movie in there or a short movie. Now, just so you know this, it does not, the system does not, when you create one of these types of fields here, it does not put that into the database itself. Did you hear what I said? It does not put it in the database itself. It puts the address in memory where the beginning of that object exists. It would be too cost prohibitive to actually put that in there. All right? And imagine if you needed it in a bunch of different tables. Would you, if you've got a movie in there that's 4 gig, would you really want that all over the place? I wouldn't. All right, it's going to be a waste of space. Not only are there blobs, which a blob, anything in here that you see with blob means binary large object. But there's also things for text. So these can hold binary data. These can only hold text. But you see, they're very similar in size. All right, and the last thing that's discussed in this chapter is how to convert data. As I mentioned to you before, if it's an explicit data conversion, the system does it for you automatically. So if you look up on the screen here, what the author is saying is, okay, if something is a number, but I say treat it as though it's a string, it'll do it. All right? You remember yesterday, one of you, it might have been you, Tony, somebody said to me when I couldn't get one of my examples to work, so I got it to work, I just put it inside of single quotes. All right? And what that did was it took a numeric value and it forced it to be a string. And that'll work, but now you can't do any calculations on that numeric value. All right? But what the system will try to do to you and for you, notice what they're doing here. They're saying take this number and divide it by an invoice number. The invoice number was set up as a string. But the system says, well, as long as it holds digits, do it anyway. All right? So it tries as much as it can. And it says here, when MySQL automatically converts one data type to another, it's implicit conversion. It goes by its own set of rules. Most of the time, it'll do what you want it to do the way you want it to do it. But if you don't like that, you can force it by using either what are called the cast or the convert functions. And that's on 234, 235, 236, and 237. And it's the end of the chapter. All right? So with cast and convert, they are explicit. Guess what? You already know how to use cast. We've done casting in C# before. All right? The only difference is when you cast, you got to use the word cast. All right? So we've done stuff like this. If I come in here and say string age equals 21, that's a string. That's got a numeric value of 0. But if I want to use it in a calculation, I can say int x equal 47 minus, and I can say here int age, and that will work. That's the way you do a cast in C#. All right? But this is how you do a cast inside of MySQL. Again, am I going to make you do cast? I don't know. I haven't written the assignment yet. So there's examples here on page 235 that go through casts. As it says, you can use cast or convert, and when you do that, it's explicit, meaning you are doing it. Notice, cast is the ANSI standard, which means rather, even though you can use cast or convert, the recommendation is you use cast. All right. Then finally on 236 and 237, they talk about how you can convert data using the format function and the char function. If you look right here, you can use the format function to convert a number to a string of characters. The char function returns a binary string for each specified integer. So what's the difference? Format converts it into a string, a regular string that you can read in a text editor. All right? Char converts it to a binary string, which you can't read with a regular text editor. All right? I showed you this before. I came in one day in class and tried to open up a Word file inside of Notepad++, and it all looked like garbage because that's a binary file I'm trying to read in a text editor. Doesn't work. So they give you a couple of examples here. All right, as it says, typically you'll use char. All right. That was it for Chapter 8. I knew it was going to be short, so let's see how much of Chapter 9 we can get done by 9 o'clock. Then we'll take a break, come back, and look at a couple more of the examples from the worksheet I gave you. So Chapter 9 starts on page 241, and it's on how to use functions. And please look up on the screen here. At the end of the chapter, this is the programming you can do in here. You can use a case. You already know that. You've used the switch statement with cases in it. It's similar, but the wordage is a little different, but you use it pretty much the same way. You can also use if null, and coalesce. That's pretty much the only programming you do in here. When I say programming, I'm not talking about adding, subtracting, multiplying, dividing, etc. I'm talking about actual programming. All right? So that's what they put in at the end of the chapter. All right. Now it says here, notice the big word here is sum on the top. Sum of the string functions. I can virtually guarantee on your next homework you will have to do something with some of these functions. I don't know what yet, but you'll have to do a bit of work. Some of them just make sense. You've already used concat. You've done that already. All right? There's concat WS. The WS stands for word separator. You'll see some examples of that in just a minute. LTrim removes beginning spaces. RTrim removes ending spaces. Trim removes both beginning and ending spaces. Again, you'll see examples. Length shows you the number of characters in the string. Then there's a bunch of different things that you can use in here to find substrings, pieces of a string within a string. You can reverse a string. You can put a string in upper or lower case. You can left or right pad a string. You can use spacing in strings, and you can use repeat. So let's look at a couple of examples. Again, this is in your book on page 245. All right, I'm not going to read any of these to you. Hopefully you can see the difference between the first concat and the concat WS. If you didn't want to write this like this, you could also just say concat last, single quote, space, single quote, first. Doing it like this is the equivalent of doing that. All right? Is there an advantage of one over the other? Not really. All right? Again, I've said this to you before, especially when you're in the first year of the program. You should be striving for understandability. So you should be doing it the way that makes the most sense to you. All right? Sometimes that's going to involve maybe doing a little bit more typing. As you get more and more well-versed, you get more and more experience, then you start looking for shortcuts. All right? I don't want to type in 100 lines if I can type in 50. Type of an idea. So here's some left trims, right trim, full trim. All right, and another way you can do full trim. All right, here this is saying trim off all of the asterisks. Do you remember that? It used to be, and I don't know if they still do it, when you'd get a check. A lot of times it would be like, let's say it was for $1.50. They would put in there like asterisk, 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 1.50. All right, they would do that so that you wouldn't try to go in there and fudge it and put another number in there or whatever. All right. They've got some good examples here that go through the substring. And the weird thing, I don't understand this, but the way it is here is the way it is in many programming languages. The thing to be leery of is when you look at left, right, substring, etc. Sometimes it starts counting at 0, and sometimes it starts counting at 1. Why would you do that? Why wouldn't you be consistent and always start counting with every function at either 0 or 1? I don't know, but they don't. There's a replace and an insert as well, and they give you an example here on the bottom of 246, which uses a bunch of these. All right. All right. This how to sort a string column that contains numbers. You may be aware of this, you may not, but if I put in, I'm going to put in 5 numbers here. All right. I'm going to put in 1, 73, 13, 26, and 8. Okay? Everybody cool with that? If I was sorting these numerically, I'd say it's 1, then 8, then 13, then 26, then 73. Does that make sense? But if these are strings, it goes like this. 1, 1, 3, 2, 6, 7, 3, 8. Because if they're strings, it looks at the first character. And that's how it's doing it. So it can be a pain in the butt to want to be able to go in and sort a column that's got a string full of numbers. So what they show you on page 247 rather is how you can do this. So if you do it this way, it's not going to work. But notice you've got to cast it as a signed integer. And once you do that, it works just fine. Now it says here, well, yeah, you can also do it like this and do a +0 there. And that's implicitly doing it. I will tell you this. This is my opinion for whatever it is or is not worth. Anytime you got your choice where you could do something implicitly, letting the computer do it, or explicitly, meaning you can do it, most of the time at least, I'm going to pick explicitly. I'm not going to trust that the software is always going to do something the way I want it to do it. All right, so I'll do it explicitly. That way, if it doesn't work, it's all on me. All right? All right. I've said this kind of thing before to you. If you look on the page in your book here, what is this? This is a page, right? The page is part of a chapter. The chapter is part of a section. The section is part of a book. And on this page, we've got paragraphs. The paragraphs are made up of sentences. The sentences are made up of words. The words are made up of letters, etc. So why am I telling you that? Because what I'm showing you is how things are naturally parsed or broken down. All right? So when you parse a string, typically what you're doing is you're going through the string and you're looking for something. You might want to be looking through a list of names and find out how many people, for example, how many people in that list, I don't know, have the word son in their name. Wilson, Anderson, etc. All right, that would be an example. Maybe not a good one, but that would be an example of how you could parse your way through a string. There are a lot of different functions that you can use. And as I mentioned to you before, if you look in here and you start looking at what's in here. In fact, if I just go out and type in here, MySQL string functions, and I hit enter. All right, notice they've got this. W3 Schools has this, which isn't bad. All right, so you can always look in there, but I'm not sure if that's complete or not. But what I should find eventually is this from the reference manual. So I click on that, and that shows me, watch this. Those are all the string functions. My guess is there's somewhere around 25 of them. So again, as always, when you're looking through this stuff, you're like, I don't know where this is, etc., etc. Always go to the documentation. All right. Numeric functions. The main numeric functions are shown here on page 251. And again, I'm sorry I'm sounding like a broken record, but I came here and it says string functions, right? I'm going to try to change this from string to numeric functions and see if it finds that. Numeric functions and operators. All right? So there's all the number stuff. Now there's going to be some stuff in here you're probably very rarely, if ever, are going to use. There are things like trigonometric functions. I remember, well, hard to believe this, but I was a smart ass when I went to school, and I remember talking to my math teacher once and saying, why the hell am I ever going to need to know the cotangent of a negative 412 degree angle? Why? He said, I can't give you a really good reason for that, but I guess it depends on what you're going to do for a living. Okay, I guess that was fair enough. All right. But the point is, that was one of the trigonometric functions I had to learn for class, but I never used it in real life. I already showed you, for example, I've shown you the round function. I showed you that yesterday. All right. I've mentioned to you before the absolute value function. If I'm 61 and Jesse's 23, there's 38 years between us. Doesn't matter if I say 61 minus 23 or 23 minus 61. There's still 38 years between us. All right. Again, all these cosine, sines, you're probably never going to use these. You might use the ceiling function. All right. Returns the smallest integer value, not less than the argument. All right. The ceil and the ceiling. You might use different conversion functions. Since there's a ceiling function, there's a floor function. All right. Again, ln, log, those are logarithmic functions. You're probably not going to use those. Notice here, mod. You can use either the word mod or the percent sign like we've used. All right. Either one of those should work. There's a pow and a power function to raise things to a power. Round I already mentioned to you. All right, there's a square root. There's a truncate. All right. Again, there are examples here in the book on the middle of 251. This, again, is the kind of thing you might use a lot or literally you may never, ever use. All right. How to search for floating point numbers. All right. This is the big thing right here. If you look at this example, hopefully what I'm about to say makes sense to you. How many numbers exist? I'm asking you this question. How many numbers exist between 0.99 and 1.01? How many? An infinite number. Because we didn't say here how many decimal places to go to. If it's how many are between there to 2 decimal places, then it's pretty small. Then the only one between there is 1.00, right? All right? So it just depends on what it is you're doing and how you're wanting to do it. All right? I showed you the round already. The big thing, as they say there, is floating point numbers are approximate. All right? Date time data on page 254. Here are things that you can do with dates and times. This will give you the current date or the current time. All right. Here's how you can parse the current date and the current time. In other words, if I just want to pluck out the hour or the month or whatever or the year, I can do that. And they give you examples of these on page, must be about 257. There's another function in here that's called extract. Another way you can parse dates and times. All right. Many people find using this clearer because you put everything in there. So if you notice in here, I want the seconds from here. All right. As far as formatting dates and times, well, you will get a chance to do a little bit of this on your next assignment. You know, again, do I want to format today like this, like I showed you before, 033-27-2018, or do I want 3-27-18, or do I want March 27th, 2018, or do I want 2018-03-27? May have asked you this question before. I don't know if I did or not. What is the universal, you know, we do stuff like this, right? We say like 327 or we say 327. What's the universal character for separating dates? Anybody know? It's a period. Many countries would do this. That's how they would specify the date. All right? And MySQL should understand and recognize any of those. But you have to tell it to format it the way you want it to be formatted. All right? So they show you some common codes here, and then they show you a few examples on the bottom of page 261. All right? Next, turning up to page 263, look on the screen here if you would. 1, 2, 3, 4, 5. Those are the main things you can do with dates. You can add time from one date to another. You can subtract 2 dates, and there's 2 ways you can do it. You can tell how many days since a certain time something has happened, etc. And in fact, there's 1, 2, 3, 4, 5 here. If I go back to where we were, right here, and I change this to date functions. Page not found, of course not. Because it's called date and time functions. All right, you look and you say, well, there's a lot more. Yeah, but many of these are just working with the time. All right. The main ones are the ones that start with date. And they're the same ones that were just shown in your book right here on page 263. Searching for dates. You don't have the problem searching for dates that we just talked about. You know, when I said how many numbers exist between these 2 numbers, Evan said an infinite number, which was correct. But if I say how many days, days are there between March 1st and March 31st, there's a finite number. All right? So you can search for dates, you can search for times. All right? And the chapter ends with, starting on page 268, and the last four or so pages on here are on programming. So please look up on the screen. I'll want you to do this because you know how to do it already. What we've done in the past is we've done something like switch, and we would have said terms ID. Case 1, we would have done this. Case 2, we would have done this. Notice there's no break in here. All right? And the syntax is different. Notice it's a select statement. So what do we want? The invoice number, the terms ID. But if the terms ID is a 1, then we want to say after these two things, net due 10 days, or net due 20 days, or 30, or whatever. That makes sense? All right? This is programmatic. It really is. It's programming. And you can do it this way, or as you'll see on the next page, you can do it using an if statement. This probably would be a little cleaner. All right? Notice when we look at this, just so you see the syntax, when you do a case, you need at least one when. You don't need multiple whens. You don't need an else. But it's just like when we wrote switch statements. Typically you have multiple cases, and typically you have a default case at the end. But you don't have to. And finally, on pages 270 and 271, this ends the chapter. It says how to use if null, and coalesce. All right? It says you can use the if function to test a condition and return one value if it's true and another value if it's false. For instance, it says you can return yes if the vendor city is equal to Fresno and no if it's not. I mean, you could think of all sorts of ways you could check this out. You could be checking genders. You could be checking a range of ages, all sorts of stuff. Both the if null and coalesce let you substitute. Hear that? What if I want to say, if you don't have a middle initial, I want a period there. Does that make sense? I don't know why you do that, but let's just say that's what you wanted. All right? So if Jesse doesn't have a middle name, he wouldn't have a middle initial. But rather than it saying Jesse null more, it would be Jesse period more. All right? You could put something else in there, but typically that would be the kind of thing. Say, well, I could put an X in there. Nobody's got a middle initial of X. That isn't true. All right? You really wouldn't want to put a letter in there between A and Z. That wouldn't make sense. A number would be confusing. So a period would be something that maybe would work. But in those examples, when you use the if null and the if coalesce, you want to replace null with something else. All right? So there's some examples here again, what we just looked at. All right? Select the vendor name. If the city is Fresno, say yes. Otherwise, say no. It's a contrived example. You might raise your hand and go, you know what? Why didn't they just put the vendor name in the vendor city? Why did they put yes or no? That's confusing. They're just trying to show you how this is used. That's all. And I always look at this, if I can come up with an example, one or two examples, and have you do them on a worksheet where it makes sense, I'll do it. But if the examples are stupid, I think it's a waste of your time to do stupid examples. All right? And again, coalesce and if null work very similarly to one another. All right, so notice we're saying here, if the payment date is null, you write no payment. And they show you two ways you can do the same thing. All right, so that's it. What that means is tomorrow, when you come in here, tomorrow, Wednesday, we will go over Chapter 7, because it'll give you a little bit more time, because this is the hardest chapter that we go over. All right? But after that, that's it for this section. So Thursday will be lab for the entire period. What I'm going to shoot for, I'm hoping I can do it, is tomorrow night to go and create your next worksheet. It won't be due until like a week from the following Monday, whatever that is. And I lied to you yesterday, not on purpose. But you may or may not remember this. Next week, Thursday, next week, Friday, I won't be here. I'm taking the students to the Skills USA contest in Lynn, Missouri. We're leaving at 7 o'clock Thursday. We're coming back around 4 o'clock on Friday. All right, so I'm taking 3 students to that. The wall will be open. Mr. Knott will be taking attendance. All right, and if you say, oh, that's okay, I'll just leave at 8 or I'll leave at 9. He'll be looking. He will probably end up walking in here. I asked him if he had any problem with that. He just laughed. Not at all. Okay, fine. So he will be doing that Thursday and Friday of next week. We may set it up. I'm going to ask him what works best for him. We may set it up that there'll just be a piece of paper here, and you put your name on it. But, I mean, if he looks and there's 2 of you in here and all 9 names are in there, he's not dumb. All right, he's a very intelligent person. Then he'll probably say, okay, who is this? And he'll call your names. I know that it's real tempting when you don't have an instructor here. Well, I'm not going to come then. Some of you are getting real close on the number of days. Remember that after 4 days, if you miss 4 days, unexcused, you've got to sign a piece of paper, and so do I. The 5th day, you got to go to Mr. Corrigan. The 6th day, you've got to go to Mr. Sutton. The 7th day, then they start thinking about kicking you out. I don't want anybody in here to be kicked out. I want all of you back next semester. All right? All right, so it's 8:55. Let's come back at 9:10, and I'll go through a few more of the examples from the worksheet. All right? I can keep this?
Yeah.
Okay. All right. Thanks for letting me know. Whatever it is, I hope it goes okay.